Okay, welcome back. We're doing question 6. Quick look at the marking scheme. We see there's just straight up 20 marks for this. We can look at the breakdown, but we're getting 20 marks for this one single question. It has no parts, it has no subparts. 80 students in a group were asked what they had done during their summer holidays. I'm going to add that information by saying the size of the universal is 80. Some of the students got a job, some went on holidays, and some didn't. Some did both, some did neither. Okay, the regions, the 1, 2, 3, the 4 typical regions you'd expect when you have two different attributes being in a two-set Venn diagram. Okay, so a fifth of the students in the group did neither. So we calculate a fifth of 80, and we get 16 out here in this region. A fifth of the students, yeah, we did that. 25% of the students got a job. 25% of 80 is 20, and we're going to put that in a bracket next to the job set. Of those 20, of those who got a job, half also went on holidays, but that means we can put 10 here, and that means we can put 10 here in the job only section. So the intersection region gets 10, the job only region, it's an important word you start to use, region of a Venn diagram, gets 10. Okay, work out the total number of students in the group who went on holidays. So we're looking, so let's read that carefully and know we're trying to put the answer here of what went on holidays. But in order to do that, we know we need to calculate this. And this is what's left over after 80. Okay, so 80, take away everything else that we already have, these three numbers, is 80. Take away 36 is 44, which means I can add 44 here and I can answer the question, which is 54. You may use the Venn diagram to help. So I'm done. Let's see how we did. There's the marking scheme saying there's 20 for this, and here's the answer. 54 went on holidays, and you get full 20 marks for getting that right. 10, 10, 44, 16. Just to say they should really be in square brackets if we want to be very consistent on our notation. It's been a very short video, so we're going to take a quick look at what sort of stuff of the learning outcomes for sets. Use and understand. So before this, the A and the B, you can look it up yourself. They're the typical things you'd expect in sets. So I just want to go over and give you a quick revision of sets. So do you know how to use and understand suitable set notation and terminology, including the null set, which can be written this way or with an empty braces bracket. Do you know what a subset is? That it has this symbol or this symbol. Do you know what the complement is? The complement of A, the complement of A, okay, or the complement of A. It's not A, isn't it? It's this region here. Do you know how to say element? A is an element of this set of vowels. This symbol. Do you know what the universal set is? Do you know what the cardinal number means? Do you know what intersection is? Union, set difference, often called only. Do you know the natural numbers, the integers, the rationals, the reals, and the irrationals? Can you perform the operations of intersection and union on 2 sets and on 3 sets? Can you perform set difference, this one, and complement, this one, but it's just the one with not everything outside? Include the use of braces to define the order of define the order of operations. Okay, so there is when we're doing union of 3 sets, are they associative? Can we do them in any order we want? Is A union B equal to B union A? And if it is, what does it mean? It means that they are commutative. Union is commutative. Investigate whether the set of operations of here we come with what I just started talking about. Set of operations of intersection, union, and difference are commutative and or associative. Commutative, 3 plus 5 equals 5 plus 3. Associative, 3 by 4 by 5, where you do the 3 by 4 first, is the same as 3 by 4 by 5. So associative is when you have 3 elements, and it doesn't matter which one you do first. And not only is multiplication and addition associative, so is union and so is intersection, but not so for set difference. Okay, that's it. It was a very simple question. We'll do question 7 next. As usual, I will see you in the next one.